time domain analysis of amplitude modulation. So first of all, I am taking AM modulated signal equation. S of t AM modulated AC into 1 plus Ka into M of t into cos of 2 pi FCT. Here Ka is 1 by AC. So 1 by AC, the units of this one is 1 by volts, volt inverse. So volt inverse, then volt volt get cancelled, then finally which gives the this analysis. This explains the amplitude modulated signal equation. Now here I want to separate these terms here. So to separate this term purpose, again I am writing the expression AC cos of 2 pi FCT. So AC cos of 2 pi FCT plus AC into Ka into M of t into cos of 2 pi FCT. So M of t explains the modulating signal. M of t explains the modulating signal. So finally the AM modulated signal consists one carrier signal, and here M of t into cos of 2 pi FCT is there. So two signals multiplications are there. So whenever two signals are multiplied, one signal frequency is maximum frequency is FM and another frequency is FC here. Then in product form it gives the two frequencies, one is maximum frequency, another is minimum frequency. The maximum frequency is summation of the individual frequencies of these two signals, and minimum frequency is subtraction of individual frequencies of these two signals. So finally which gives the one representation like this. Here one carrier frequency is there, and in this FC plus FM one signal and FC minus FM one signal. So AM modulated signal consists totally three parameters. One parameter is carrier and another parameter is upper sideband and lower sideband. So upper sideband, lower sideband and carrier signal. So these are the parameters of AM modulated signal. All these signals are connected to the antenna. Antenna converts the electrical signals into electromagnetic waves and electromagnetic waves into electrical signals. A transmitting antenna converts the electrical signals into electromagnetic waves. To convert these electrical signals into electromagnetic waves, internally it requires some power, right? So now we have to calculate the power calculations of the signal. So according to the number of frequencies in the modulating signal, this amplitude modulation again classified into two types. One is single tone modulation, another is multi-tone modulation. So, right? So single tone amplitude modulation. Single tone, that name explains the modulating signal has only one frequency. So if the modulating signal has only one frequency, then the modulation process is called single tone modulation. That's why here I am assuming modulating signal is AM cos of 2 pi FMT like this. So AM cos of 2 pi FMT. So just I am taking here sinusoidal signals. For single tone modulation, always we have to consider modulating signal consists only one frequency. That purpose I am taking here sinusoidal signals. That sinusoidal signal here I have assumed with cos function. If you want, you can take sine function also, either sine function or cos function, anyone we can take. But generally cos function simplification is very easy because it is a even function. Then spectrum analysis and time domain simplification purpose also cos analysis gives the easy simplification. That's why here I am taking cos function, right? And another type of modulation is there, that is multi-tone modulation. Multi-tone AM. So multi-tone amplitude modulation, here we have to consider the modulating signal has more than the one frequency. So more than the one frequency, then the modulation is called multi-tone modulation. That purpose here we have to consider the signals are like this. M of t is equal to M1 of t plus M2 of t plus M3 of t plus and so on. That is depends on the number of informations. More than the one information. So more than the one modulating signal frequency. So this signal consists one frequency, this signal consists another frequency, and this signal consists another frequency. So each signal has separate frequency is defined. So more than the one frequency is defined, then the modulation process is called multi-tone modulation. Now I am assuming like this, which has different amplitude also. I am taking different amplitudes here. AM1 cos of 2 pi FM1t plus m2 of t is nothing but here am2 cos of 2 pi f m2t plus am3 cos of 2 pi m3. So different frequencies we have to take here. So this type of modulation is called multi-tone modulation. First of all, I will explain single tone modulation, time domain representation, frequency domain representation. Later we will go through the multi-tone modulation, right? So please take this now. Modulating signal m of t is am cos of 2 pi fmt. This gives the modulating signal. So modulating signal has only one frequency. The frequency is how much here? FM frequency. Now I want to substitute this complete equation in this. Then the AM modulated signal gives here AM modulated signal equation consists AC into 1 plus Ka into AM cos of 2 pi fmt into cos of 2 pi fct. So now finally which gives here Ka into AM. This gives the modulation index. Ka into AM is also called as modulation index. So this is denoted as mu, or sometimes we can write with M representation. M is nothing but here modulation index. Already we have discussed that Ka is nothing but 1 by AC. If you substitute that value here, then finally this mu value becomes here AM by AC. AM is nothing but the maximum amplitude of modulating signal, the maximum amplitude of the modulating signal, and AC is nothing but maximum amplitude of the carrier signal. The ratio of maximum amplitude of the modulating signal to the maximum amplitude of the carrier signal is called modulation index. So this gives the standard definition of the modulation index, that is mu is equal to AM by AC. If the mu value is less than the 1, then the modulation is called under modulation, right? And mu is equal to 1, then it is called critical modulation. If the mu value is equal to 1, so mu is equal to 1 means critical modulation. It is also called as 100% modulation over modulation process. In amplitude modulation, generally the preferable value is mu is less than or equal to 1. Generally used, right? Generally used mu value is less than or equal to 1. If it is less than the 1, under modulation, equal to 1 critical modulation, greater than the 1 also possibility is there, but that is not used, because if it is follows the greater than the 1 or over modulation, demodulation process becomes very difficult here. Demodulation process, that means again we have to convert this high frequency signals into low frequency signals. That process becomes very complex thing. That's why this is not used, right? In over modulation condition, demodulation process becomes very difficult. Generally preferable value is mu value should be less than or equal to 1, right? Then finally the AM modulated, single tone AM modulated signal consists this equation. Then I want to write separate terms here. So I want to substitute here mu, then the equation becomes here like this: AC into 1 plus mu into cos of 2 pi FM into T into cos of 2 pi FCT. This is one of the standard equation. Please remember this equation. AM modulated, single tone AM modulated signal equation is AC into 1 plus mu into cos of 2 pi FMT into cos of 2 pi FCT. In this, mu explains the modulation index. FM explains the maximum frequency of the modulating signal, and FC explains a maximum frequency of carrier signal. Then I want to separate these terms now. This is equal to AC cos of 2 pi FCT plus multiply these terms now. It becomes AC mu into cos of 2 pi FMT into cos of 2 pi FCT. Now two cos functions are in product form here with the different frequencies. One frequency is FM frequency, another frequency is FC frequency. Now this is similar to this equation here, cos A into cos B, cos of A into cos of B. Then this explains 1 by 2 into cos of a plus b. From the trigonometric, I am taking this equation now. Cos of a plus b plus cos of a minus b. AC cos of 2 pi fct plus here AC into mu by 2 because 1 by 2 is there. Cos of a plus b, cos of a plus b becomes like this, 2 pi fc plus fm into t, right, plus AC mu by 2 into cos of a minus b. So a minus b means this one I am taking first here because cos of minus theta becomes cos theta, so it does not affect. That's why I am writing like this, 2 pi fc minus fm into t. Because fc is a carrier frequency should be always high frequency, and fm is modulating signal frequency, that frequency is low frequency. That's why I wrote here fc minus fm. Otherwise, if you want, you can write fm minus fc also. So both are same representation because cos of minus theta is equal to cos theta. Now finally, the AM modulated signal consists totally 3 terms. Those terms are carrier, this is also called as carrier, and this is called upper sideband. Because here fc plus fm is there, so carrier frequency adds with modulated signal frequency. That's why it becomes another new frequency, higher frequency. It's also called as higher cutoff frequency or upper sideband. And one more is lower sideband, lower cutoff frequency, fc minus fm. Carrier frequency subtracts from the modulated signal frequency subtract from the carrier frequency. So this gives the lower cutoff frequency or lower sideband. AM modulated signal consists totally 3 terms. One is carrier, another is upper sideband, one more is lower sideband. This is one of the very important point. The bandwidth of AM modulated signal is like this, 2 into FM. Because generally the bandwidth explains the higher cutoff frequency minus lower cutoff frequency. Higher cutoff frequency is here FC plus FM minus lower cutoff frequency is here FC minus FM. Then after simplification it gives the 2 into FM. So what is FM here? Maximum frequency of the modulating signal. So finally the bandwidth of AM signal is 2 times of modulating signal frequency, that is FM. So 2 into FM. This explains the bandwidth of AM. This expression is also called as time domain expression. Single tone modulation, time domain expression. Similarly, we have to discuss frequency domain representation. So first of all, I will explain the graphical representation of this equation, because we have to draw the graphical representation for single tone modulation, and later I will explain the frequency domain representation. So please take this now. So amplitude modulated signal consists 3 parameters: carrier signal, upper sideband and lower sideband. Now we have to discuss the graphical representation of AM modulated signal, amplitude modulation process signal here, right? So to understand the graphical representation purpose, here I am taking modulating signal and carrier signal. These two signals are sinusoidal signals. So AM cos 2 pi FM into T. FM explains the maximum frequency of the modulating signal. That frequency is low frequency signal. Now I want to draw the graphical representation of M of T. So this is now assuming modulating signal with respect to time axis. Now the frequency of this signal is low frequency. So low frequency means time period should be very high, because time period and frequency, these two are inversely proportional. If the frequency is very low, time period of the signal is very high, and this signal is cos function. So the max amplitude is here AM amplitude. So that's why I am drawing now AM modulated signal. This is AM modulated signal. So the max amplitude is how much here? AM. And negative axis side minus AM is there. So this explains the AM cos of 2 pi FMT, because cos function exactly at frequency is 0. This part is 0. Cos of 0 is 1. 1 means here AM. So maximum amplitude is there. Cos 90 it becomes 0. And cos 180 again it becomes minus 1, so that is minus AM, and this explains the graphical representation of cos function. And similarly, now I want to draw the carrier signal now, C of T. C of t carrier signal is AC cos of 2 pi FCT. Now in this, AC explains the maximum amplitude of the carrier signal and FC explains the carrier signal frequency, right? So that's why here I am drawing the graphical representation of the carrier signal is like this. And one more important point is, this carrier signal is very high frequency signal. Carrier signal is very high frequency signal. So FC value is very high frequency, high value here. So if the frequency is very high, time period of the signal should be very less. So that's why here I am drawing the complete carrier signal in between two amplitudes. So the maximum amplitude of carrier signal is AC, negative side maximum amplitude is minus AC. Now the complete signal is like this here. So cos function is nothing but it is a sinusoidal signal. This sinusoidal signal amplitude is varies in between two limits here. So maximum amplitude is AC, negative maximum is minus AC, and this is cos function, and this is very high frequency signal, right? It is high frequency signal. That's why here I have wrote the time period of the signal is very less. This explains the time period of the carrier signal. And here the time period of the carrier signal up to here we have to take, right? Peak to peak. And similarly, the time period of the modulating signal. The time period of the modulating signal is very high. This explains the time period of the modulating signal. So modulating signal frequency is low, so time period is high, and the carrier signal frequency is very high, so that's why time period of the signal is very low. Now these two signals are individual signals. So these two signals are connected to one modulator circuit. Here I am taking one modulator circuit. Modulator. So which type of modulation? Amplitude modulation. So modulating signal is connected here, the M of t is connected here, low frequency signal is connected here, and carrier signal is connected here. This is C of t. So it performs the modulation process. That modulation process is here AM modulation, amplitude modulation process. Then finally which gives the S of t, modulated signal. Now we have to draw the graphical representation of modulated signal. So to draw that purpose, first of all I am assuming here this modulated signal amplitude is AM and maximum amplitude of the carrier signal is here AC. So these two amplitudes, I am taking one condition. The condition is one representation if AM value is less than the AC. One condition I am taking now. Maximum amplitude of the modulating signal is AM and maximum amplitude of the carrier signal is AC. So if AM is less than the AC, so amplitude of the modulating signal is less than the amplitude of the carrier signal, then what happens here? Modulation index should be less than the 1. If the modulation index is less than the 1, then I want to draw the modulated signal. This is modulated signal. See, to draw the modulated signal purpose, first of all we have to combine these two. And according to the definition of AM modulation, amplitude of the carrier signal is changes with respect to amplitude of the modulating signal. So whatever the amplitude here, this amplitude is directly affects on the amplitude of the carrier signal, because amplitude modulation is nothing but amplitude of the carrier signal is changes with respect to amplitude of the modulating signal. That's why first of all I am assuming the amplitude of the carrier signal is this much. Let us take here amplitude of the carrier signal is AC is there, and negative axis side minus AC, right? So this amplitude is not constant now. This amplitude is changes with respect to amplitude of the modulating signal. So whatever the amplitude here, these amplitude combines here. Here how much amplitude is there? AC. And here how much is there? AM. This AM adds with AC. That's why already AC is defined here. Now I am taking up to this part is AM here. So this becomes now AC plus AM. AC plus AM. Then finally the maximum amplitude becomes here this much. And similarly negative side it becomes here minus AC minus AM. Right? So the amplitude of the modulating signal is changing like this. Amplitude of the modulating signal is changing in this parameter. And similarly, the amplitude of the modulating signal negative axis side is changing like this. Then what happens here? Amplitude of the carrier signal is changes. So this carrier signal amplitude is changes. So this amplitude becomes now AC plus AM, and here this amplitude is slightly decreases because amplitude of the modulating signal is decreases. So this is also decreases. Then finally this amplitude becomes very less here, minimum amplitude here, and again maximum amplitude here. Right? So what is the frequency of the signal? Frequency of the signal is Fc. The frequency of the signal is Fc. So there is no changes in the frequency. Which parameter is changes? AC is changes. Right? So AC is affected. AC is affected because of this amplitude of the modulating signal. That's why amplitude of the carrier signal is changes with respect to amplitude of the modulating signal. Now here I have wrote this amplitude, AM modulated amplitude up to this gap here. This gap up to here because just now we have assumed here AM is less than the AC. And sometimes our expected questions are like this. Another condition I am taking now, second condition. If AM is equal to AC, both are equal, then what happens here? If both are equal, then the modulation index is 1. It is also called as 100% modulation. It is also called as 100% modulation. And another name of this one is critical modulation. What about this one? Under modulation. So this is one of the very important graphical representation. You have to understand this part carefully here, right? So now again I want to draw the modulated AM modulated signal with this condition. With this condition, the condition explains AC and AM both are equal. So AC is defined up to here. Then AC plus AM. Let us assume the position is here. If AC and AM both are equal, then the amplitude of the modulated signal here, this is touches here, because both are equal now. Similarly, this side also I am assuming here minus AC, and here minus AC minus AM. This amplitude is also exponentially, sinusoidally decreasing, and again it touches here. Then the amplitude of the modulating signal is changes with respect to amplitude of the modulating signal. Amplitude of the carrier signal is changes with respect to amplitude of the modulating signal. So this type of output signal is expected if it is follows this condition, AM is equal to AC. And here AM is less than the AC is there, that's why here it has some gap is there. Here it has some gap, right? Then here there is no gap because AM and AC both are equal here. So both are equal. This type of waveforms are expected if the modulation index is 1 or if it is follows the 100% modulation, right? So this is one more condition, and another condition also there, if AM is greater than the AC now. If AM is greater than the AC, then the modulation index is greater than the 1. If the modulation index is greater than the 1, this type of modulation is also called as over modulation. This type of modulation is also called as over modulation. In over modulation, what happens here? So in over modulation, amplitude of the modulating signal is very high, very high. That's why whatever the amplitude here, this amplitude is enters into the negative axis side. Now it enters to negative axis side, and this side, whatever the negative amplitude is there, this enters into the positive axis side. Then what happens here? It performs here overlapping operation here, right? The AM modulated signal consists only this part. Here AM modulated signal is there, right? And again it performs overlapping here, and again it becomes like this. So whenever the two amplitudes are overlaps, then immediately the receiving means reconstruction process becomes very difficult here. That's why here it performs the overlapping operation. So here it is overlapping is there. So this operation is nothing but overlapping. To avoid this drawback, it has to, AM modulator has to follow one condition. The condition is always mu is less than or equal to 1. The preferable modulation index value is less than or equal to 1. Then it gives the under modulation or critical modulation. In these two cases, drawback is not there. That means reconstruction process is very easy. But here, the reconstruction process is very difficult because to find this exact amplitude is not possible here. So to find this negative and positive, both are overlaps here. So then finding of exact amplitude is not possible. That's why this type of modulation index is not used in practical cases. So here one drawback is there. Detection process becomes difficult, right? So detection process becomes difficult. This is the drawback of over modulation condition. So in AM modulation, the preferable modulation index value is less than or equal to 1. This value is used. So here I have explained the complete graphical representation of AM modulated signal. Now I want to define modulation index. So already we have discussed the modulation index. It is the ratio of amplitude of the modulating signal to the amplitude of the carrier signal. And again we have to write this modulation index in terms of maximum and minimum amplitude of modulated signal. Now already we have discussed, just now we have discussed this part here. This is AM modulated signal. AM modulated signal. Now from this I want to define modulation index of AM signal. So modulation index explains the AM by AC, right? So in time domain expression there I have explained this part. Modulation index is AM by AC. So what is the amplitude of the carrier signal? That is AC. Now we have to write these two ratio here, right? So that's why here I have defined mu is equal to AM by AC. Now I want to define this AM and AC from this signal. From this signal means this is AM modulated signal. After modulation process it has maximum amplitude and minimum amplitude also there, right? So this amplitude is maximum amplitude. This explains the maximum amplitude, that is A max, right? And this amplitude is minimum amplitude, that is A minimum, right? So A max is A max here. I'm writing in terms of A max, right? So A max is there, A minimum is there. Now I want to write this A max and A minimum in terms of AM and AC. A max explains this term here. This is equal to AC plus AM. So now I'm writing equation here. A max is equal to AM plus AC. AM plus AC. And similarly A minimum I'm writing now. A minimum means this amplitude here. So this gap is, how much gap is there? The complete amplitude is here AC and this amplitude is here AM, the subtraction of these two. So which explains here AC minus AM, right? A maximum is AM plus AC, A minimum is AC minus AM. Then I want to add these two. So if you perform the addition of these two, then it becomes like this: A max plus A minimum. A max plus A minimum becomes here AM plus AC and AC minus AM, then it becomes here 2AC. Then finally AC is equal to amplitude of the carrier signal is equal to A max plus A minimum by 2. Now similarly I want to perform subtraction of these two now. If you perform the subtraction operation, what happens here? A max minus A minimum. So this equation minus this equation, then AC get cancels, then it gives one more equation now, A max minus A minimum, right? This minus this, AC get cancels, now AM and AM, these two adds here, and it becomes 2 into AM. Then write the AM equation from this. AM equation is A max minus A minimum by 2. A max minus A minimum by 2. So this explains the AM means maximum amplitude of the modulated signal, and this equation explains the maximum amplitude of the carrier signal. Modulation index is the ratio of these two. Then find the ratio of these two now. So directly which explains the modulation index. If you find this ratio, then finally which gives you this equation: maximum amplitude minus minimum amplitude by maximum amplitude plus minimum amplitude. So after AM modulation process, the maximum amplitude is this much here. So this value minus this value by this value plus this value, that explains the A max minus A minimum by A max plus A minimum. This is another standard equation. You have to remember these two equations. According to the given data, we have to substitute any one equation here, right? One equation explains the maximum amplitude. This max amplitude is modulated signal max amplitude. Maximum amplitude of the modulated signal is A max. Maximum amplitude, minimum amplitude of the modulated signal is A minimum. So subtraction of those two by addition of those two. Then directly which explains the modulation index. This is also one of the very important equation. These two equations are important, right? So please take this now. AM modulation, amplitude modulated signal consists of three parameters. One is carrier, upper sideband and lower sideband. These three parameters are connected to the antenna. So antenna function is which is used to transmitting antenna function is which converts electrical signals into electromagnetic waves. Now all these signals are now electrical signals. So one carrier signal parameter, upper sideband parameter, lower sideband parameter, all these are electrical signals. Now antenna has to convert these electrical signals into electromagnetic waves. To convert these electrical signals into electromagnetic waves, it requires power, right? That electrical power. Now we have to discuss how much power is required to transmit this signal, right? So to transmit AM modulated signal, that is explained by power calculation. So now the topic is power calculation. Power calculation. Power calculation of which modulation? AM modulated signal, right? So to find out the power calculation, so how much power required to transmit AM modulated signal? First of all, we have to write a AM modulated signal equation, that is functional representation. Now I am writing that equation now. AM modulated signal consists, I will write that part here, right? S of t, AM modulated signal consists here. One parameter is AC cos of 2 pi FCT, carrier signal, right? Plus, and another two parameters are there. One is upper sideband, another is lower sideband, right? So totally three parameters are there. This parameter is also called as carrier signal, and this parameter is also called as upper sideband. This parameter is lower sideband, lower cutoff frequency. So which consists totally three parameters. From this, now I want to write here amplitude of carrier signal, right? Amplitude of carrier signal is how much? Here, this is AC. From the AM modulated signal I am writing now here. So AM modulated signal consists totally three parameters: carrier, upper sideband and lower sideband. The maximum amplitude of the carrier signal parameter is here AC, and similarly the maximum amplitude of upper sideband. The maximum amplitude of upper sideband. So how much amplitude is there here? Mu AC by 2. So mu AC by 2, right? And similarly one more maximum amplitude of lower sideband. Maximum amplitude of lower sideband here. Lower sideband parameter is this one. How much amplitude is here? Mu AC by 2. So mu AC by 2. And another important point is here. See, the modulated signal is available in these two terms here. Because here this is pure carrier signal. Here it has only one frequency, FC is there. And this upper sideband signal consists FC plus FM. So modulated signal consists in this, and modulated signal again defined in this. So that's why the modulating signal is available in upper sideband and lower sideband of AM modulated signal, right? And finally we have to find out the power here. So to find the power of sinusoidal signal, we have to take the standard equation, average power equation, that is normalized power equation from the sinusoidal signal. So now let us assume one signal is defined like this here. X of t is V sin 2 pi ft, right? X of t is V sin 2 pi ft, or it is V cos of 2 pi ft. V cos of 2 pi ft. So in this, what is V here? V is a amplitude of the sinusoidal signal, right? V is a amplitude of sinusoidal signal. Then the average power of this signal, is maximum amplitude whole square by 2. This power is also called as average power or normalized power. For sinusoidal signals, the maximum power, average power or normalized power equation explains the maximum amplitude whole square by 2, right? Otherwise, sometimes we can write like this. This is equivalent to, your maximum amplitude is how much here? V. So V square by 2, or sometimes we can write here V square by 2 into R. So R is resistance of the antenna. Right? So if the resistance of antenna is not given, so not mentioned, then immediately we have to take normalized power. So that normalized power is V square by 2. That's why I wrote here approximate equation. What is V here? V is nothing but maximum amplitude of the sinusoidal signal. Now from this, I want to find out the carrier power. So internally 3 parameters are there. This is carrier, upper sideband and lower sideband. Now I want to write a carrier power equation. So carrier power is, now I am writing with PC. So what is the standard equation? Maximum amplitude square by 2. So your max amplitude is how much? AC. So AC square by 2. Then finally which gives the AC square by 2. Approximately we can write AC square by 2, or if you consider the resistance of the antenna, if it takes the resistance of the antenna, then the equation becomes AC square by 2R from the voltage and resistance equation, right? And similarly here, carrier power is finished. Then I want to write a upper sideband or lower sideband power. Because the amplitude of the upper sideband and amplitude of the lower sideband both are equal. That's why directly I am writing now amplitude of the power of upper sideband is equal to power of the lower sideband. Then the equation explains maximum amplitude. How much amplitude is here? Mu AC by 2. So maximum amplitude whole square by 2, right? Maximum amplitude whole square by 2. Then write the equation now. Upper sideband power is equal to mu square AC square, and here 2 square becomes 4, and 4 into 2 is 8. So mu square into AC square by 8. This is equal to, you can write like this, PLSB also. So lower sideband power is mu square into AC square by 8. Upper sideband power is mu square into AC square by 8. And carrier power is AC square by 2. If you want to write in terms of resistance, write here R also, right? So these are the standard equations. And from these equations, we can write few points here. The amplitude, the carrier power does not depend on the modulation index. Mu is not there here. Mu is not defined in this. That's why carrier power does not depend on the modulation index. But upper sideband power, lower sideband power depends on the modulation index, right? So it is depends on the mu value. Then we have to write the total power equation. So the total power is nothing but to transmit all these parameters. AM modulated signal consists carrier signal, upper sideband and lower sideband. To transmit these 3 parameters, it requires summation of individual powers, that is PC plus PLSB plus PUSB. We have to find out first of all individual powers and later take all this power summation, because we have to transmit all these parameters, carrier, upper sideband and lower sideband. Then substitute those equations here, then which gives here AC square by 2 plus lower sideband power is mu square into AC square by 8 plus upper sideband power mu square into AC square by 8, right? Then simplify that. If we simplify that parameter, So AC square by 2 is, I am taking common outside, then the remaining equation it becomes here 1 plus mu square by 4 plus mu square by 4, then this is equal to AC square by 2 into 1 plus mu square by 2. AC square by 2, AC square by 2 is nothing but carrier power. So final equation, total power of AM modulated signal is carrier power into 1 plus mu square by 2. This is one of the standard equation. You have to remember this equation, because sometimes we can expect some problems from this equation also. So how much power is required to transmit following a modulated signal? So for that purpose, first of all we have to find out carrier power, and later modulation index of the given signal, and then find the total power. And from this equation I want to write mu equation also, modulation index, right? Square root of another standard equation here, mu is equal to square root of 2 into Pt by Pc minus 1. So this is the another standard equation. So modulation index in terms of powers, modulation index in terms of amplitudes, AM by AC, modulation index in terms of maximum and minimum amplitudes. So then write A max minus A minimum by A max plus A minimum. These are the different equations of modulation index. Modulation index using amplitudes and max amplitude, minimum amplitude, and using powers. So this is also one of the very important equation. You have to remember this equation. Power calculation of AM modulated signal. Total power is equal to Pc into 1 plus mu square by 2. So please take this now. AM modulated signal is given here. So AM modulated signal is 10 into 1 plus 0.5 into cos of 2 pi into 10 to the power of 3t into cos of 2 pi into 10 to the power of 6t. This is equal to this equation. So AM modulated signal is given here. So immediately we have to assume this equation, we have to compare this equation with our standard AM modulated signal equation. The standard AM modulated signal equation consists like this. Now from this we have to write immediately given parameters, because now the question is here, find out all these parameters. So find all these parameters from the AM modulated signal. So to find that purpose, first of all I am writing here given data. Generally the given data is here. One is AC is there. Just compare these two equations. Amplitude of the carrier signal is how much here? 10 ohms. Amplitude of the amplitude units are ohms, right? And compare these two equations. Here we will get mu is modulation index. Modulation index is how much here? 0.5. This is equal to AM by AC. So already we have discussed modulation index is AM by AC. Now here AC is 10, right? Then from this, now I am writing here AM. How much AM is there? AC is 10, multiply here, then which becomes here, amplitude of the modulated signal is 5 volts. So AM is also finished. Later compare these two again. Here cos of 2 pi into 10 to the power of 3t is given, and here cos of 2 pi into FM is there. So that's why according to this given data, maximum frequency of the modulating signal is how much here? 10 to the power of 3. 10 to the power of 3 is nothing but 1 kilohertz, right? And similarly here 2 pi into 10 to the power of 6 is given, and here FC is there. So carrier signal frequency is how much here? 10 to the power of 6. This is 1 megahertz. 1 megahertz, or we can write 1000 kilohertz in terms of kilo and in terms of mega, because one more frequency is in terms of kilo is there, so we have to define in terms of kilo also. Upper sideband frequency. Upper sideband frequency is FC plus FM. Upper sideband frequency, or it is also called as upper cutoff frequency. FC plus FM. FC is here 1000 kilo plus FM is 1 kilo. Now it becomes here 1001 kilohertz, right? And similarly, lower sideband frequency, lower sideband frequency is Fc minus Fm. So now it becomes here 1000 kilo minus 1 kilo. 1000 kilo minus 1 kilo becomes here 999 kilohertz. And from these two I am writing now bandwidth. Generally, what is the standard equation of the bandwidth? The bandwidth is equal to upper sideband frequency minus lower sideband frequency. Upper sideband frequency minus lower sideband frequency, this is equal to 2 into Fm. 2 into Fm. Fm is here 1 kilohertz is there. Then finally which becomes here how much bandwidth? 2 kilohertz. The bandwidth of AM modulated signal from the given specifications here, given data, the bandwidth becomes how much here? 2 kilohertz. And from all this, I want to find out these amplitudes also, right? So amplitude of upper sideband is equal to amplitude of lower sideband. Both are equal, right? Amplitude of the upper sideband and amplitude of the lower sideband, these two are equal, and that equation is mu into AC by 2. Mu into AC by 2. Substitute those values. Mu is modulation index. Modulation index is how much here? 0.5. 0.5 into AC is 10 by 2. Right? So 0.5 into 10 is 5. 5 by 2 is 2.5 volts. Upper sideband and lower sideband amplitudes are 2.5 volts. The maximum amplitudes 2.5 volts. And later we have to find out carrier power. Carrier power, normalized power, because here resistance of the antenna is not given. That's why I am writing now AC square by 2. AC is 10. 10 square by 2. Now it becomes here how much? 50 watts. Carrier power is 50 watts. Now from this I want to write total power also. Total power. Total power standard equation explains PC into 1 plus mu square by 2. Substitute all the values. PC value is here 50 watts. 50 into 1 plus mu is 0.5 whole square by 2. 0.5 whole square is 0.25 by 2 is 0.125. Then 1.125 into 50, this becomes here how much? 56.25. Approximately I am writing now 56.25 watts. To transmit this AM modulated signal, antenna requires how much power? 56.25 watts. So total power, carrier power, modulation index, bandwidth, and upper sideband, lower sideband. So all these parameters are finished. Just here I have explained how to find all the parameters, AM modulated signal parameters from the AM modulated signal. So here I have explained one example. So please take this now. So just now we have discussed the AM modulated signal standard equation explains AC into 1 plus mu into cos of 2 pi FMT into cos of 2 pi FCT, or we can write in this format also, upper sideband and lower sideband. For that purpose, first of all, we have to find out the modulation index, right? So now I am writing modulation index mu is equal to AM by AC. Modulation mu is equal to AM by AC. Here AM is how much? 10, and AC is also 10. Then becomes how much here? 1. Then this is comes under 100% modulation. If the modulated signal M of t and carrier signal C of t, these two are given, from these two here modulation index is 1. So that's why it's also called as 100% modulated signal, 100% modulation process, right? Now from this I want to find out, I want to write, first of all I want to write a AM modulated signal equation. AM modulated signal equation requires AC into 1 plus mu into cos of 2 pi into Fm into T into cos of 2 pi into Fc into T. So for that purpose we want here maximum frequency of the modulated signal and maximum frequency of the carrier signal. Now just go through this one here. This is similar to this equation AM into cos of 2 pi into Fm into T, right? So please compare these two equations. Here we want 2 pi into Fm into T, but here the equation is 4 pi into 10 to the power of 3t is there. That's why From that, we can write the maximum frequency is how much here? 2 kilohertz. That is 2 into 10 to the power of 3. Right? Because here 2 pi, standard equation explains always 2 pi f. But here 4 pi is there. This equation we have to write 2 into 2 pi f. So 2 into 2 pi f, that's why it becomes here 2 kilohertz. And similarly, the carrier signal frequency is how much here? 1 mega. 1 megahertz. In terms of hertz I'm writing now. Now write AM modulated signal. AC is 10 into 1 plus mu. Mu is how much here? 1 into cos of 4 pi into 10 to the power of 3t. Right? Into cos of 2 pi into 10 to the power of 6 into t. Now from this, I want to write carrier power. Carrier power explains the AC square by 2. Here AC value is how much here? 10 is there. So finally which gives the 50 watts. And again I want to find the total power. Total power is equal to PC into 1 plus mu square by 2. Mu square by 2. Then substitute those values. 50 into 1 plus mu is 1. 1 square by 2, then it becomes 1.5. 1.5 into 50, that becomes here approximately 75 watts, right here. So 1 by 2 is 0.5. 1.5 into 50, 1.550 is here 75 watts. So these type of questions are expected from the AM modulated signal. Total power is given and carrier power is given. AM modulated signal consists totally 3 parameters. One is carrier, one is upper sideband, another is lower sideband. Now carrier power is given. The remaining 2 parameters are upper sideband and lower sideband. So the total sideband is nothing but combination of upper sideband and lower sideband. That's why we can write the standard equation is like this. Total power is equal to carrier power plus upper sideband power plus lower sideband power. Upper sideband power, lower sideband power, these two are always equal, right? Always equal. That's why I'm substituting all these values here. 75 is equal to 50 plus upper sideband plus lower sideband. Then upper sideband plus lower sideband power is how much here? 25 watts. So this is sideband power. The total sideband power is how much here? 25 watts. And we have to find out the modulation index. Already we have discussed the standard equation of modulation index from the total power. So 2 into PT by PC minus 1. Then substitute these values here. Total power is 75 and PC is 50. 75 by 50. 75 by 50 becomes here 3 by 4, right? So 3 by 2. 75 by 50, then it becomes a 3 by 2. So 3 by 2 minus 1, it becomes 1 by 2. The modulation index becomes here how much? 1. So this type of questions also expected. So AM modulated signal, maximum amplitude is given and minimum amplitude is given. From these two we have to find out modulation index. So already we have discussed the modulation index, another standard equation also there, that is maximum minus minimum amplitudes by maximum plus minimum. Right? So what is Amax here? Amax is nothing but maximum amplitude of modulated signal. So now modulated signal maximum amplitude is how much here? 7 volts. Then substitute that value here. 7 minus 3 by 7 plus 3. 7 minus 3 is how much? 4 by 7 plus 3 is 10. Then it becomes here 0.4. The modulation index is 0.4. Then the percentage of modulation is how much here? 0.4 into 100. Then it becomes a 40% modulation. How much modulation? 40% modulation. These are the different methods of questions are expected from the AM modulated signal. Up to now we have discussed time domain representation. Similarly, we have to discuss frequency domain representation, then how to draw the complete frequency spectrum of AM modulated signal. Right? So please take this now.